Hi everybody, let's talk about transform plate boundaries, or some of you may call it conservative plate boundary. It occurs when two plates are moving alongside each other, either in the same direction at different speeds or in different directions due to underlying convection currents. We can draw it in a diagram. Usually you can't really draw it the same direction or anything with a 2D model, but you can draw a 3D models like this. And then you can draw one also like this, and just draw blocks like Minecraft. There you go. And then you draw either the same direction, or you can draw different directions as well, or you can add the convection currents in if you want. But it's more difficult to draw it than other ones. But that's about how you draw it. Landform wise, you have earthquakes. Because the buildup of pressure here, you might have different rocks and stuff. So it might get pivoted in or something, it might get stuck, and they still want to move, but they're getting stuck. So it builds up pressure, builds up tension, and after a while, it will release all the tension in the form of earthquakes. You also have transform faults, which are essentially just the movements of them. And you have fault scarps, which can draw it like this. You can draw a cross section of a fault scarp. So this has to be like a fault line, like a sideways, and then you can draw a depressed block as well. So this block kind of moved up and this one down because of the earthquake in the center over here. So we can move on to our real life examples. The San Andreas fault line is a good example of a major fault scarp or transform fault. The North American plate and the Pacific plate moving in different directions, and Haiti struck with an earthquake in 2010, really devastating because of the movements of the North American and Caribbean plates. That sums it up for transform plate boundaries. Hope you guys enjoyed, and I'll see you in the next video.